Hi, today we are going to talk about the association, which is more general than the correlation. We know we have a correlation coefficient, correlation coefficient. You have two types of correlation coefficient, right? When you have your variable is quantitative data, right? Quantitative data, and when you have qualitative data. For this one, we go for person or Spearman. Do you remember this one? We go for person. Person. Correlation coefficient. We know when you have qualitative data, you have two types, right? You may have ordinal or nominal, right? You may have ordinal. If you have ordinal data, you go for what? You go for Spearman correlation coefficient. Okay? Today, we are going for the nominal. Nominal means you have colors, you have names, you have type of blood. So we can manage with this too before. What about the nominal one? So today we are going to use something called chi-square. We heard about it before. So yes, this is we are going to use chi-square.
The screen is not clear for me.
Sorry?
There's something blocking the screen. I can't see it. Yes, I can see it now.
Okay. Sorry. So for the nominal data, you go for chi-square. Okay, the chi-square test just give me there is a relation or not. Okay, but how I can measure the strength of this one? I can measure the strength by something called the phi coefficient. And some people using phi square, but I prefer phi. Okay. Now, again, when you go for correlation, okay, you have two types of data, quantitative and qualitative. For the quantitative data, you can use person correlation coefficient. For the qualitative data, you have two types. If you have ordinal, so you can go for Spearman correlation coefficient. But if you have a nominal, you have something called phi coefficient, which is found using the chi-square value, right? Okay, so we used to have two things, right? We used to have x and y. And I have y equal to ax plus b. This is the regression equation, right? Now, if I have value here, I can make the scattered plot, and I may have this is the best value for me, so this is y equal to ax plus b. This is the regression equation. Also, if these data are quantitative, it means x and y are interval or ratio, right? Interval or ratio. You remember the variable measurement? Yes, you have variable measurement could be interval or ratio, okay? And you know the difference between this one is a zero. If you have the definition of zero, zero is known, like the temperature and the time. Zero time, it means you have nothing, but zero temperature doesn't mean you have nothing, okay? Because you have Fahrenheit and Celsius, okay? So this is when you have quantitative data, so you will go for, you have a correlation coefficient, right? You get the correlation coefficient between x and y. You have the formula for this one. This is what? This is Spearman or person. Yes, if you have quantitative, you go for person correlation coefficient. So this is what they call it, what? Person. This one is a person correlation coefficient. And you use t-test to test this one, right? Or fx and y are qualitative, ordinal, I mean, you go for person, for Spearman. Okay? And both you are going to use t-test to check this one. And you have the null hypothesis. It means in this time, if you use the t-test to check the correlation, so you said rho equal to 0. Rho is the correlation for the population, right? And the alternative hypothesis, HA, is rho is not equal to 0. This is the t-test for the correlation. Okay. But if you have x and y like years, okay, if you have years here or time, so you can order the time. And if you have level of education, you can rank the level of education. So if these one are ordinal, okay, so if x and y ordinal, so you go for what? Yes, you go for Spearman correlation coefficient. So you have R, this one, it's called Spearman correlation coefficient. Okay. Also, you can use t-test to test this one. Also use t-test to check. Okay. Also, the null hypothesis is rho. This is the correlation coefficient for the population equal to 0, and the alternative rho is not equal to 0. Okay. Today, I'm talking about coronavirus, and they said, I'm saying maybe from 0 to 12 year, they have no problem. From 12 year to 18, maybe from 18 to 24. And I get this one to 40, say, and from 40 to 50, I can make it group, right? So this is age group. This is age group, okay? I classify my patient or my positive cases into groups, but these groups, it is not a number, okay? This is like you say, and say you have gender. This gender has two categories, male and female. So we are going to check positive cases and negative cases or died. Okay. So I can check the link between the gender and the coronavirus positive cases, and people died from coronavirus. Can you use any correlation of the one you know before? Of course not, because you don't have linear relation, because this is linear regression. Okay. Also here, I have only two stuff, right? And also it is linear regression. Even if I have more than this one, when I used to have more than, I have y and I have x1, x2, x3. This is the independent variable, and I have one independent variable. So this is a dependent variable. And all of these ones are the independent variable. Okay? Yes, this is, I call what? I call this, in this case, I have a multi-linear regression, if you remember this one. Multi-linear regression. So what is the difference in this case? Yes, in this case, I have independent variables, and each variable has no categories, right? But this one, I call it age group or age categories. So this is, I call it what? This is the categories. Categories of one variable, right? Of the variable. What is my variable? Which is the age, right? So yes, when I have category for the variable, I cannot go for the correlation coefficient, right? Linear or multilinear. So I will go for, in this case, also male and female. I have, this is categories of the variable. What is my variable? They call it gender, right? So yes, in this case, I cannot use the linear regression or multilinear regression. Also, I can go for countries here, right? I said Asia, okay, and USA and Europe. So in this case, you cannot go for the multilinear regression, right? So we are going for what? Yes, we go for chi-square. Chi-square. Now we will start with chi-square. So we'll go for chi-square. We use chi-square to do what before? We use chi-square to say there is they are equally distributed, the expected value or not. And we call this one chi-square test for we use chi-square test for what? For goodness of fit. This is what we have done, right? Okay. And today we are going to use it for what? For association, right? For association. Because we fail to use the multilinear regression. So yes, in this course, we use the chi-square twice. Once for goodness of fit, and the other one association for the association, right? So what's the question in this case? The question was what? This thing. Okay, testing what? The expected value to the observed value, right? This is what we have done so far. Today we are going to do what? I'm saying, for example, if I'm asking you for the male and female, I go for the variable gender, I know this variable is a nominal, right? So I have male and female. Okay. If I'm asking you, would you like which flavor of the pizza you prefer, right? So I call for pizza number 1, pizza number, sorry. So I classify pizza call it P1 and pizza number 2, pizza number 3, because I'm not good in the name of the pizza. And I'm saying the question is there a relation between gender, I mean male or female, and the preference of pizza type, pizza type. This is a normal question, right? So you wait the people coming to the pizza outside, and you have just question, and you write the name of the pizza, and ask the male and female, and get the observation, and count how many one like P1, how many one like P2 from the male, and also from the female. Now, you can check using chi-square what I'm going to explain right now, okay? There is a relation between the gender and the preference of the pizza or not. But in this case, he didn't mention the strength of this relation, right? So yes, I go to have something called phi. This phi is exactly, this is a phi coefficient, exactly like the correlation coefficient person or sperm. It is the same, working the same thing. This phi is chi-square over n, as we see now, right? So you know the point of our lecture today. Yes, we are going to answer the question if there is a relation between two variables, and each variable has different categories. We have the questionnaire, and we know we are checking the gender and the preference of the type of pizza or anything else. Or I may ask a question, good, very good, excellent, okay, and the preference of the choice, depend the male or female or not. This type of question you would like it to have it in the questionnaire, okay? And the strength of this association, we are not going to say relation this time. We say association is better and more general than the relation, okay? And how to find the strength of the relation? This gives you the strength of the relation. This explain the strength of the relation. The strength of the relation. Okay. Now I will stop this one and we'll go for our presentation. You can see the presentation now, right? I start with this title, different scales, different measures of association. Again, as I said, depends on your variable. If your variable is ordinal or interval or ratio scale, it means in this case, it means your data is quantitative. In this case, or that one, it means your data is qualitative. If your data is quantitative, go for Pearson correlation coefficient. And the value of this one between -1 to +1. From 0 to 0.5, it is weak relation, positive. From 0.5 to 0.7, some boxes write it 0.75, you have a fair, moderate positive relation. Above 0.7 or 0.75, up to before 1, it is strong positive relation. And you can talk about the same thing about the negative relation. Also, the same thing about the Spearman rho or Spearman correlation coefficient, but in this time, you have qualitative data, but your variable is ordinal scale, like level of education, like military service ranking, like years, okay? So you have no problem with this one. You have a linear relation. Maybe if you have two variable, one independent, one dependent, you have simple linear relation, or simple linear regression. But if you have more than one independent variable, you have multilinear relation, okay? But you cannot deal with nominal scale, like colors, names, blood type. So this is why we are going for Pearson chi-square. But Pearson chi-square is not like this one, like the correlation coefficient. This one gives me the strength of the relation, as I explained, from 0 to 0.5, weak, from 0.5 to 0.7, or sometimes they write it 0.75, it is moderate, above 0.7 before 1, strong. If it is 1, exactly it will be very, very strong or identical. But this chi-square is just, chi-square test is just telling you there is association or not. But there is a coefficient, we call it phi. We will go for it. Yes, here it is. This phi, sorry, I have to correct this one because I write it chi-square over n. Chi-square over n is phi square, but by mistake I make it phi. Okay. This is a point. Again, chi-square is a coefficient giving you the relation, the strength of the relation. Okay. So let's go. This is a chi-square distribution table, and you know it before because we use it. You need only the degree of freedom, which is a sample size minus 1, and you need your alpha, which here is they call it probability. And you remember you have only one tail in this case, so you don't worry. Yes, you divide, no need to divide alpha by 2, right? Straightforward, you have only one tail in this case. Because this is a square, when you have a square stuff, it is always positive, so you don't have two critical values. You have only. As we said, yes, I have more than one categories, male and female with the gender variable, type of pizza, Mexicano, fajita, margarita. So you have more than one category of the pizza. And the observation must be independent observation. It means you don't ask anyone, okay, and ask him again or change his mind for the other stuff or get somebody to make a bias for special type. And the sample size, at least you have 10. So you have to do at least 10 observation, 10 questionnaire, I mean. Okay? And must be randomly. Don't go to your friend and ask them to fill the questionnaire. Okay? All the observation must be used. Okay? Don't say, yes, I will take the observation, which is, for me, it will be good for my research. No. Have you done it randomly, so you take all the observation, okay, in your account. For the test of to be accurate, the expected frequency should be at least 5. It means what? It means the frequency equal to 5, so at least 5 they're choosing this one, right? The sample size must be 10, but at least the frequency not less than 5. Okay, we know this one. We know this formula before. Chi-square is the sum of the observed value minus the frequency. This is F for frequency. The observed frequency minus the expected frequency square over the expected frequency, right? So we know it before and we use it in the chi-square test for goodness of it. How to get, we need for the chi-square, we need a degree of freedom and alpha value or the level of significance we are going to test for. The degree of freedom in this case, as I said in the table, we have category as a rows and categories as a column. So you count how many categories in your variable in the rows and subtract 1, multiply by the number of categories in the columns minus 1. Let's go for this example. I make this questionnaire for the male and female. I have 50 male and 40 female, okay? And I ask them to get that only one choice, favor, neutral, or opposite, okay? I find 10 go for favor, 10 for neutral, and 30 opposite. And for in the female, I have 15 favor, 15 neutral, and 10 opposite. For the chi-square, what you are going to do in this case, not like the goodness of fit. You say the expected value are equally distributed. No. The expected value here, you have to calculate it by what? The expected value for this one, you multiply the sum of the row by the sum of a column divided by the total sum. Okay? Let's go for this one. So yes, this is the sum of rows and this is the sum of columns. For this one, This is my observation, right? What is the expected frequency or my expected value for how many one choose the favor, right? How to get it from the observed one? I multiply the sum of rows by the sum of columns and dividing by the total number, right? Let's do it for another one. For this one, yes, I know how many one because I fill my questionnaire and I know 15 observation for the favor. But what about the expected one? I have to calculate it by multiplying the sum of row, this one as a row, and columns, right? I multiply the sum of the row by the sum of column, dividing by the total sum. Now, after I finish this operation for each cell here, I'm going to sum them very similar to the chi-square for goodness of it. So I have the chi-square stat. Now, look at this one. How many categories in this one? I have 2, right? So I have to subtract 1 from this one. So I have 1. How many categories here? 1, 2, 3. I have to subtract 1, so I have 2. So the degree of freedom will be what? 1 times 2. So the degree of freedom is, and this alpha will be given to you, right? This level of significance will be given to you. Okay? So yes, I can choose my alpha if it is not given, and I can. How I can look for the chi-square for the degree of freedom 2 and alpha is 0.05. I'm looking for alpha, which is here in the chi-square distribution table. It's called the tail probability P. I'm looking for 0.05. Here it is, right? And the degree of freedom is 2. So yes, this is 5.99. So my chi-square critical is 5.99. And my stat value is 11 something, right? So yes, if I sketch this graph, this 11 will pass this 5 on the right side. So I'm going to what? Yes, I'm not going to accept the null hypothesis. So I will reject it. Okay? In this case, what is the null hypothesis for this one? The null hypothesis for chi-square saying what? There is a relation between the preference of the male and female, right? So there is an association between the gender and the preference in the choice, okay? How to measure the strength of the association? I just said it now, right? How to measure this one? By phi, right? So this phi, if you look at this one, phi is always positive, right? Not like the correlation coefficient, not like the Spearman, not like the person, right? It is positive value. So you will have from 0 to 1, not from -1 to 1. And the small one telling you weak. Okay, let's go for that. Next example. Okay. Look at this one. You have opinion, agree or disagree. In this case, you can make chi-square in this case, and you can make chi-square in this case, and you can make chi-square in this case, and you can check the strength of the relation between the gender, the opinion and the gender, right? Also here, I have the opinion, agree, disagree, and I have male and female. So when I get it, I get chi-square equal to this one, and I have n equal to this one. How I know it is 150? Because if I count all of this one, 75 plus 25, 100, plus 250 plus 250 is 150. What is the chi-square? This one. I prefer phi. How to find phi? Phi is the chi-square over n. So you divided 9.375 over 150, which is 0.25. But in this case, you get chi-square is 3.125. You get the sample size here is 65 plus 25, 90, plus 35 is 125, plus 25 is 150. If you divided the chi-square by the 150, you will get the phi value. The phi value is 0.1. So in this case, the association is weaker than this one, right? Similar in this case also. So the strength of the association given by phi. Phi is equal to what? Chi-square, the stat chi-square, divided by the sample size. The sample size, you count all of these numbers, right? Or the total number, as I said in the previous thing. Okay, phi is 0.25 for the strong relationship and only 0.144 for weak relationship. So this one is stronger than this one. Okay. Now, the chi-square test is important to us, especially when you do a questionnaire and we have the observation, our observation, which is frequencies, and we have a nominal data. So in this case, we cannot go for linear regression, whatever it is, simple linear regression or multilinear regression. So we have to go for chi-square test to test the association. Okay, so the chi-square test tell us there is association or not. How to find the strength of the association? We can divide the chi-square by the sample size to have the phi value, and in this case, if the phi value is bigger, so we can say this is strong. Now, here is your assignment. How to test the relation between age and weight from the following sample. This is the age, right? So how many categories you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? How many categories of weight you have? 1, 2, 3, 4, 5. No, sorry. This is what? This is a linear regression equation, right? So no need for chi-square in this case, right? Because I have two variables. Of course, the weight depends on the age. So I can go for what? For simple linear regression and Spearman or person in this case. Yes, it is quantitative data. So I'll go for person correlation coefficient. So this part for the correlation coefficient. What about if I, instead of you dealing with this table, I got the table like this. I divided the age into two categories, below 28, above 28. So in this case, the linear regression is not working, okay? Because I have category in this case. This is not categories, right? This is quantitative data, okay? This is interval value. And also, this is also quantitative data. So we can test the relation using the correlation coefficient, person correlation coefficient. But the same data, if I split it into two categories, say the age, I make two categories of the age, and also for the weight, I make two categories. So in this case, in such table, I cannot use the linear regression, okay? Because I don't have dependent and independent. I have categories of the dependent, and I have also categories of the independent. So I will go for what? For chi-square. Chi-square again, test will tell you there is association between these two categories and these two categories or not. How to measure the strength between these two categories and these two categories? By phi value. What is the phi value? It's chi-square, root square of chi-square over n. This is assignment 2, part 2. Here, it's very clear. You have two categories of the patient, some with heart disease and some with no heart disease. And the same patients having categories of cholesterol, high cholesterol, or low cholesterol. Again, here you cannot use the linear regression or the correlation Pearson or Spearman. So you have to go for chi-square. Now, how to do this one? You don't have chi-square test in Excel, right? Okay, so you have to do it by hand. How I can do it by hand, I will let you know now. Let's open Excel file. Okay. Stop sharing this one. I'll share the Excel. Okay. Before I leave, I take this one. Snapping. Yep. You can see Excel only now, right? Now, I'm just writing. I'm copying this one here. Disease. No heart disease. Okay. And here, high cholesterol. Okay. And low. Okay. Now I'm just typing the number. How many observation you have from the patient? 15 patient who having high cholesterol and heart disease, and 8 having high cholesterol and no heart disease, and 7 having low cholesterol and heart disease, and 10 having high cholesterol, no heart disease. Okay. Now, let's do how to do it by hand. In this case, as I said, I have to get the expected value, right? So I will have the same table as this one, okay? But for this is the observation, right? This is what? This is the observation. Okay. Now I'll go for the expectation, right? So I'll go for the expectation. Before I go for the expectation, I have to sum the row and the column, right? So here, 15 plus 7, 22. And here you have 18. Here you have 23. Here you have 17. Okay. Let's go for having the expectation of this one, right? I will have the same, so the total here will be what? 22 plus 18 equal to what? 40? Yes. Is it 40? This one is a total number. So I will choose by a different color. Okay. Slightly bigger. Okay. this is very important to you because all the time you're dividing by this one, right? So yes, I'll have the same one here, Control C, and I'm using this type, okay, to have the same format. Okay. Now, I'm not going to take this one, but this one will be the expectation, right? So this is, I call it FE, right? This is the observation as FO, right? Okay. Now, how you can find this one? We said use press equal to calculate anything in Excel. So what you are going to do, you multiply this one, right? Multiply, it means star. Sorry. You multiply what? The sum of the row multiply the star by the sum of column, right? Dividing by this total number, right? So I press equal, so I get this expectation value, right? Do you think if we drag this one, we'll have the right answer? No, because in this case, you don't have a symmetric calculation in this case. But I can press equal. For this one, I go for the sum of its row, right? Shift and 8 to make multiplication. I'm dealing with which one? With this 8. So also I'll go for this one, right? Dividing by this one. So I press it. Okay. Now this equal. For the 7, I go for its row and its column. So I multiply this one, shift and 8, by its column, okay, divided by the total number. Press equal. Now, press equal. This is for number 10. So I'll go for the sum of the row of number 10 and shift and 8, and the sum of the column of number 10 divided by the total. Now I have the expected value, right? So next, what I'm going to do, I have to use a formula for chi-square. What's chi-square? Chi-square is a sum of FO minus FE, right? This is chi-square stat. This one is equal to 1. This one is the observation. So I get the chi-square for each cell, right? Let's go for the first one. So I should have exactly, I go for this one. It's better because it has no equation. Now, I'm not going to take this one. I'll go for the chi-square for each cell, right? Okay, I'll go for this one. What is the chi-square? For this one, I press equal, okay? I'll go for the first one, which is 15, right? So I open bracket because I'm going to square this 15 minus the corresponding expected frequency, close it, square it, divide by what? By the expected, right? So by this one again, so press equal. So this is my first chi-square for the first cell, right? For high cholesterol and heart disease. Okay, I'll go for the second one, which is 8. So I press equal, open bracket, y bracket, because I'm going to square what inside the bracket. What inside the bracket? FO minus, oops, sorry, I have done this one. I have to go for the second one. This one, FO minus FE. This 8, no heart disease and high cholesterol. No heart disease and high cholesterol. So this one. And square it. Divided by what? By the expected one, right? I get the chi-square for this one. Okay. Now I'll go for the low cholesterol with the heart disease, which is this 7, right? So I press equal to calculate anything in the cell. I have to press equal and I open bracket because I'm going to subtract FO minus FE square it divided by FE. Now I have the chi-square for this one. The last one equal, open bracket. This is the last cell, FO minus FE. This one, low cholesterol with no heart disease, which is exactly FE, this one. Okay, square it divided by FE. Yes, this is the whole, this is the chi-square stat, right? For each cell. But the chi-square, the total chi-square, this is the one I'm looking for, right? So I press equal and I have to add all of them, right? This one plus, you can go anywhere because you have to sum all of them. It doesn't matter if you go for rows or you go for columns, right? So now I have the 4. This is my chi-square, right? Yes, I have to shade this one. This is the one I'm going to compare with the critical one. This is a bad choice. Do you have the table for chi-square? Let's go for the chi-square critical, right? Chi-square critical. It is a chi-square. I need the degree of freedom, and I need what? You need degree of freedom and alpha. I didn't mention alpha when I'm talking about the test. So it depends on you. Choose alpha as you like, right? So what is the critical value? So before I'm talking about alpha, I'm saying alpha here, which is I'm going to insert. I have a symbol here called alpha, where it is. This is alpha. Okay, so I can insert alpha here. Thank you. I can make it slightly bigger. Okay, this is alpha. What do you think? What's alpha you need me to choose? Choose any alpha. Go for 5%, 0.1, 0.01, 1%, okay? Just to change from, make it bigger. Now I choose 0.01, okay? So I'll go for the degree of freedom of what? What is the degree of freedom in this case? How many categories I have for the column? How many columns I have? 2? Yes. So the degree of freedom, I have to mention the degree of freedom here for my case. Degree of freedom equal to what? How many rows you have? 2. So I have 2 minus 1 times, I have also 2 columns, so 2 minus 1. So the degree of freedom equal to what? Equal to 1, right? So yes, I'll go for my table for the degree of freedom equal to 1 and alpha equal to what? 0.1, right? If you have the table, give me the critical value, please. So you'll go for P equal to 0.01 and go for the degree of freedom is equal to 1. Okay, I will share the table with you.
Doctor?
Yes, I will share it just to show them how to use This one, okay. So I'm going to share this one with you to see. Yes, it is. Now let's go for the table. Can you see the table? Yes. So I'll go for the degree of freedom is 1 and my alpha is 0.01. Where is 0.01? Here it is. So critical value is what? 6.63. The degree of freedom is equal to the number of column minus 1 multiplied by the number of rows minus 1. I have 2 rows and 2 columns. So 2 minus 1 times 2 minus 1. So I have 1. So the degree of freedom is 1. My alpha, in this case, I suppose it 1%. So I will go for 1%, 6.63. Okay. So now I'll stop sharing this one and get back to my Excel file. So what is the critical value? 6 point what?
6.63.
63. Thank you. Okay. So I'll make it slightly bigger. Okay. Now, yes, I can compare the critical value with the stat value, right? So which one is bigger? Yes, my critical value is bigger. So the chi-stat is less than what? Less than the critical value, right? So what you are going to say in this case?
You accept.
Yes, is less than the critical value. Okay. This is what I ask you to do for assignment. You have to write everything in your Excel file, right? Don't leave it as a numbers only. Numbers is easy for everyone. So we're going to do what? We accept the null hypothesis. Sorry. What is the null hypothesis in this case? It means what? It means the null hypothesis is say there is no association, right? Which is rho in the linear regression equal to 0. But here we don't have correlation coefficient. We have phi. Okay. So you can say there is no association. So the chi-square test measuring there is association or no association. There is no association between what? Between my first variable is what? The heart disease and what? And the level of the cholesterol, right? And the cholesterol level. Cholesterol level. Okay. This is the most important sentence you are going to write. Okay. And you just make it bigger. This is very important because this is give a summary for your conclusion, right? This is a conclusion. But until now, you said there is association or no, but you didn't say it is yes. If there is no association, no need to have the strength of the association. Okay. But let us have the phi value, right? So I'll go for the phi coefficient. What is the phi coefficient? The phi coefficient is the root square of what? Of chi-square over the sample size, right? So it is equal to what? Square root. How to find the square root? Okay. You just type equal SQRT, open bracket, the square root of what? The critical or the stat? Of course, the stats, right? Divided by what? Divided by the sample size. What is the sample size? The total number, it is 40, right? So I divided by 40. Now, if I press enter, yes, it is 0.023. So this phi doesn't tell me now anything because the test telling me there is no association, right? Because the chi-square stat is less than the chi-square critical, so there is no association. So what you are going to do now in this case? Yes, I'm going to make my questionnaire again or get another sample and retest using chi-square. Okay, so this value doesn't give us any unless we have a mistake in this calculation. This is how to use chi-square test for association using Excel. If you have any question, please ask.
Sure.
Yes.
Doctor, for the degree of freedom, we have the total sample. Why we chose the category? Why we didn't minus with the?
No, this is the definition of the degree of freedom in the chi-square test for association. The degree of freedom is the number of categories of the first variable minus 1, which is if it is in the rows, those are the number of rows minus 1, and the other categories variable in the column. So the degree of freedom is C minus 1 multiplied by R minus 1. Okay.
In the chi-square.
In the chi-square for what?
Correct.
For
the critical.
Association. Okay.
Okay, for the association. Okay.
But when we use it in the test of goodness of fit, we have the sample as minus 1.
-1. Yeah, okay.
This is very good
Thank you
question,
so much.
Mihrab. Thank you for your question.
Thank you.